Всех рад приветствовать на конференции. Рад приветствовать на моем докладе. Зовут меня Сергей.
My name is Sergey. I'm from Shopify company. What we do is various types of testing, and today we'll talk about root cause analysis. I've been in testing for 13 years, and my key conclusion is one of the objectives of testing is to make this world better. If a product works well, then our customers do not lose their money or time and do not lose their market position. To assure quality, it is essential to have expected outcome. And in our products and processes, we must strive to heighten the clarity or certainty percentage. Today, we would like to cover three types of uncertainties that we would like to put an end to and get rid of. And how can we handle those uncertainties? The first uncertainty. When we worked on a large project for a telecommunications company, we got everything done, tested, and on day one, the whole work got blocked. We were stuck because the integration with the real telephone numbers didn't work. We had to put out that fire quickly. And as you understand, this is not a singular case. There are thousands of cases like that because we live in an interesting and diverse world. We have had, after we've had several cases like that, the customer might come to us one day and say, "You used to deliver better quality." It's great when we know how to manage that, because the customer might say, "You used to do better," without any evidence or numbers. We also wanted to introduce clarity and certainty in such discussions, because there are a lot of it around. So clients might say, "Your code is really something," in a negative tone. How can you even deliver that? Or they can stop by in the afternoon and tell you to give better quality without any cases substantiated. Or customers might ask, "Why do you have so many simple bugs? Don't you do in-house testing?" Or better yet, a following discourse might follow. "Why do you deliver us bugged release? Why don't you debug it first?" Perhaps this is the customer who never encountered testing before from the development field, or maybe these are customers from specific sectors where it is not customary to have defects delivered. It is hard to come to terms or to a consensus when you are engaged in discussions like that. So what we need and what we wanted to do is to provide evidence. And the third uncertainty is when our retro looks like a hammer fight, when we start a shame game. I mean, why did you miss that bug, or why did you overlook that defect, and why didn't you do integration? And that wears you out quickly. And then at the end of the day, we decide to do a training to improve the competences of our staff and the quality of our product, but we are not sure which one. So let's repeat the uncertainties. First is the one with external defects. Can we do anything about it or not? The second is about the mood of the customer, and the third is chaotic and destructive retro. So we thought, what could be the material to work with here? And we realized that we have plenty of defects that we can work with, that we can handle, and we thought that what we need is a framework, a system, because we need a conveyor principle. We cannot afford to compile an abstract essay on a given defect, then devise action, and then take that action based on a consensus. So we wanted to come up with a system that would expedite the process. And the second tenet is that once you asked 5 questions about a problem, you obtain or get a specific action. But we wanted something beyond that, something more. We wanted to have a limited number of answers. So we would think once, add structure to our process, and then follow this well-trodden path. Also, by asking 5 questions, we wanted to figure out if we really need to do anything about the problem. So we got a system of root cause analysis. This is how it looked. Now let's take it one by one. First, we unload a full list of defects and ask a question. Is it really a defect? Because in bug tracking, we might encounter not only defects, but also some other items. I mean, we worked with defects, but in fact, it's an expanded system. You can use it as tasks or questions. I mean, it is customized. It is customizable. The second question, we were interested in the priority of defect and did it work before? The defect priority, we looked at blockers and criticals. It was expensive to look at all defects, so we wanted to look at most harmful defects. Did it work or not? Before, this question will provide answer if we worked better before. Perhaps we need to revoke some of the changes that we made earlier. If it had worked before, but now it does not work, then the root cause for that defect has to do with the changes to the process or to the changes in the product. The next question we asked was whether we could anticipate or predict that defect. Our job is to anticipate a defect so that it would not affect the end user or the client. We could give a simple yes or no answer, but we were more interested in a limited number of categories. Let's look at them now. Could we foresee that defect? Yes, but we made a planning error. It means that for one reason or another, we missed this functional area. Yes, we could find a defect, but we had a code coverage error. So we wanted to cover a specific area, but we didn't write a test for this functionality. Next category, we could anticipate it, but there was a launch mistake. And we may have missed a step internally, which resulted in a defect. Next thing, the answer is yes, and it was a known error. Sometimes we release a product with defects known to us. It may have to do with the fact that the bug fix will result in multiple changes. Or we know that next week we are going to rewrite as per the new requirements of the customer. And the final in yes section is that we could anticipate a defect, but it was one of many negative scenarios, one of many negative scripts. At the code coverage phase, we try to cover as much stuff as possible, but it doesn't always make sense to do a full coverage, and we have to be reasonable and rational, especially if sophisticated systems are involved. Next category, we could not anticipate the defect because the behavior was not described in the requirements. Accordingly, no requirement. If there is no requirement, it is impossible to say how to implement. Another no in the no section is that we always have assumptions section, something that depends on our planning. And we may have not even planned to do a certain functionality, but it was tested by the customers later, and they told us, guys, you have a bug here. Next category is due to lack of server capabilities. In ideal world, we cannot afford the same environment as the customer does, and we have to interface with this somehow. I'll show you an example later. Next, no category. We could not anticipate the defect because it is data-driven defect. The system is affected, the behavior of the system is affected by the content. And the fifth category, we could not find the defect because it is a complex cause resulting from two previous ones. We may have an infrastructure filled with different data, but in parallel some processes are taking place. So, eventually, we come up with a list of defects, or rather causes of defects, if we could foresee or not, or project or not. And again, we can identify two categories. Yes, it is most likely linked to in-house activities, and we don't have to engage in dialogue with the client. And no, implying that we need to change our communications with the customer. The next question that we answered was the root cause for that. Here again, We highlighted several categories explaining what could cause the defect. First is most evident. A mistake was made in the code. It never worked before. The second, when we were trying to fix something else, we broke another thing. I mean, we were fixing the functionality, added an upgrade or a feature, and in the process broke something that worked. Another root cause is that the behavior was not listed in the requirements. No requirement, no problem, but you end up with a defect. Alternatively, we had a customer who had a clear requirement. But as you know, the information delivery chain is not as straightforward. We have discussions on the way. Perhaps an attribute was missed in the test design. Another cause for a defect is an improperly configured environment, which means we did something, tested it internally, but since we misconfigured our environment, it worked in our environment, but failed in our customer's environment. And the final cause is dependence on a third-party components. Sometimes we are not the only ones, not the only subcontractor, so we're working only on one module of a complex system. And it might be the case that the third party changed something in their components, failing to notify us, or they did notify us, but we did not make a record of that. As a result, we get another list of defects explaining potential causes of a defect. Let's provide real cases to explain how we did the review. First, recognition of numbers on a certain Cisco model failed. Could we anticipate that? Yes, we could, but there was an error in planning. We forgot about this platform. So the cause is that there was an error in the code and it never worked. So comment is evident. We made a planning error and in script review. So we added all systems check in the checklist, and the test lead will check checklists and will communicate with the team. But it's not as straightforward. Although in actuality, answers to questions, if it had worked before and if we could anticipate the reason, is a way to say or to decide if we need to take action. Should we or should we not take action? We can add quantitative attributes and the opinion of customer, because some insignificant defect can be very painful for the customer. Let's look at another example. Let's say we started testing and we noted that indexes for England's addresses did not work. We missed an entire country, England. So we didn't test it, we missed the requirement, we did not implement it, and as a result, it's not working. So the comment is more technical. A parser for English codes was not added, And then we say there was shortage of analytical testers, and they could not add it in the test case review. And then the action is not as trivial. Perhaps we don't have to do anything with this era, because we have to fine-tune to decide whether it is relevant for a specific customer. Perhaps that customer is oriented toward Asian market. And the tester may have looked it up and found that there are interesting indexes, not only with letters, but with numbers, but also with letters. And if it matters for the customer, then by collecting a certain number of defects, we might say, let's put it in our plans, or let's agree or accept that we know that this is an error. So for a post-mortem review, we may tell our managers, here's a set of defects, we had 25 of those, and let's do something about it. We either ignore it, or we plan to have more analysts to get rid of this defect in the future. Now let's look at the case that led to waste of time and money by the entire team. So, having reviewed defects, we found that we did not have a real validator of the telephone database, and we could not cover or anticipate that defect because there was a difference in environments. And the reason or the cause lied with the third party. We were not notified. The action is evident. We either need to check versus real validator or the emulator. But again, we have playing field with the customer. What if there are security risks involved and the customer doesn't want to share that database? Then we say, let's emulate it. We'll use inserts that will use your protocols and encryptions to create an emulation. Okay, but what if the customer says, no, again, for security reasons, I cannot give that to you? Then we say, if we want to eliminate these defects, we could do alpha version of the software. I will send our tester to you, and he will run tests in your environment to get rid of the errors. But the customer says, I can't let you do that, it's too expensive. Then the picture gets transparent for the next assumption or next statement. We have to deliver without bugs. So the customer realizes by using different options, they can either eliminate or accept that if we don't do anything about these bugs, then they will definitely occur in the future again. So by filling out such drop-down lists, we receive a system, and I can show you how we can use it. Let's say, some say it used to be better. From this statement, we can go to a different one. We can do the data unloading for the previous release and the current one, and see that functional defects have reduced in numbers, but general defects have increased. This gives a certain level of confidence to customer in what we do, but it also gives a playing field. We can fine-tune and work with a specific customer.
О том, что дефектов связано с
We can also see that we now have more defects related to the environment. That's why we see that, okay, we started to work with the bigger number of components. In order to replace these defects, let's focus on this particular area, which might be either linked to data or to documentation. The customer then receives a clear picture, and we could start discussing objective figures. This also gives us internal information, whether we are improving or whether we are deteriorating, thus having a trend. What if we do have a feeling and we see a stream of defects coming? We could use the same system in work. Well, for instance, when we do a similar run, we might find out that half of the defects that occurred were related to their gaps in the demands, and we can work with this information somehow. We could either use our internal kitchen, try to improve, or if we have identified the gaps caused by bad test coverage, or based on our knowledge of the internal kitchen, we can do setup of our internal processes and develop skills and knowledge among developers and or testers. The specifics algorithms of our actions is as follows. First, we upload the defects, collect the questions, collect the statistics, set up action plan, limitations, and then decide whether we act or not. Afterwards, we must check the effect of the measures taken. That is work in the system. The lessons learned in the process of implementing the system are that the analysis should be done from the very beginning. It took us 10 to 20 minutes to fill the fields of defects for each of them. And if a developer has fixed the box, and now he says, okay, it was broken after it had already been in operation. So this tool is quite transparent and it's not that expensive for a release as a whole. Sometimes a tester might see that a defect was missed because of the problem with coverage. Secondly, whether use automation or not, true, we could use Google Lists, we could use Excel sheets. However, there are faster approaches, such as, for instance, using metrics or components or some other fields in backtrack log systems. If we do like this, then when we do the upload with the support of the bulk filter, we could get the fields already filled in. When it comes to improvement of works, then such improvements should be done on a regular basis. We must see the trend, we must see the changes that occur to the trend and do fine-tuning. It is also very good to always update the system and search for new questions that we could categorize and answers. We could add weight to each of the defects and see that this particular defect was not only a blocking one, but the downtime of such a defect cost 4 hours. We could also add a field to Jira and then further act. In this particular case, we were interested in where the biggest downtime is, at which stage we made a mistake, and at which test level this error could have been spotted. Thus, the system could be extended based on your demands. I hope that this approach will help you in working both with the customer and in making internal improvements of your quality improvements of your retroactive connections. This could also help you understand and foresee certain defects on the customer side. Thank you very much. I will be happy to take all your questions. Thank you very much, Sergey, for your report. Question number 1. When you were preparing this data sheet analysis, at the beginning, automation is not used, if I understand that correctly. Did it take you much time to create such a list and keep it updated? Did you allocate this task for a separate person, or was it the task given to the whole team? In the end of the day, this work was performed by senior specialists because they were more aware of all the integration aspects regarding components and testing. It didn't take long. At early stages, it took around 20-25 minutes. But later, when the senior specialist found 5 or 7 defects, it was already clear for him how much time it would take to fill in the list. Then the senior person also knew all the aspects of the system, and it was easy for him, having such an experience, to write down actions. Actions could have also been written down. Was there any kind of a cross-review, such as the defect root cause analysis, and that all action approved of such actions, or did the team trust the expertise of the senior who did such a list? Yes, we did an internal review, and an important thing is that while working with the customer may not understand how it works. He may think that there are many defects that the team attributes to some other reasons. At the very early stages, it's important that you provide a full-scale picture to the customer, and probably it makes sense to write in detail everything related to 3 to 5 defects, so that the customer could be sure that you were not hiding anything. So, yes, we once did cross-review, but in fact we made a split, like from 6 to 9. One person is doing that, from 9 to 15. Another person was doing that, but if there was a lot of data, sometimes there were contradictions, and based on the discovered contradictions, it could have been detected if some fields had been misfilled. Did you have contradictions often? Well, it happened, especially at the beginning, because those were people's opinions, and at the beginning we had to try to possibly even describe the actions, such as develop a handbook. Then in future, when a senior understands how it works, he could delegate this problem further. He could describe, let's say, a kind of a defect related to JPEG, and it was already reflected in this or that release. We also tried to document in the handbook all the contradictions that occurred. Yes, thus we accumulated experience. Yes, we did. Thank you. Thank you, Sergey. Thank you for your presentation. It was very interesting. My question is about efficiency of quality assurance in your division. What's the percentage of bugs that you allow for in your RCA table sheet? Are there any tough assessments when this Excel sheet is being reviewed? We didn't show this sheet to the customer because it contained too much information. If otherwise, additional training with the technical specialists of the customer would have been required for him to understand every single detail. We only made an abstract from a bigger sheet and worked with the diagrams of the kind as shown in the slide because they provide more clear visual picture. But it depends on the customer and on the customer's targets and on the targets in general, what kind of scope of information should be provided. It also depends on the amount of work that is performed, scope of works that are performed. It also depends whether the project is new or whether the project is already ongoing. First, we were interested in taking certain metrics, and later, based on the accumulated data, included data from other projects, we could have confirmed whether everything is going in the right way or not. So I think we should use our experience in such kind of things. Thank you very much for your report, Sergey. My question is that, if I understand it correctly, the target of implementing such a system is to reduce the number of errors. Do you have a real indicator confirming that the system was effective? For instance, the number of defects declined. Yes, there is. We used similar kind of diagrams for each single release. We could evaluate whether it makes sense to apply this tool. Some of the actions worked in one project, however, were not working in the other one. Since we were using the system, it provided a clear picture and gave us clarity for the whole process and gave us understanding of the quality of our product. So the next stage is to monitor that the number of errors reduces if the system is being applied, right? Well, yes, if you are using the similar table, you could track for their releases what's going on. We can assess what happens in each release, release 1 and the next one. Also, we started to calculate how much it costs and how much the implementation of other steps cost. Sometimes implementation of certain actions didn't lead to a significant increase. That is why when people were doing cross-review, we realized that it took us a lot of effort but didn't give cost benefit. That is why we were looking at different solutions. Thank you for your presentation. You mentioned that a defect appeared because it was not written in the requirements. Was it really a defect? I'm asking because sometimes a customer would like to make certain big additional developments, calling it a defect. How do you solve such kind of problems? Well, it's quite a typical case. But you have to work specifically with a particular customer. If it's for us, it doesn't cost much internally, and for us, we left it as a defect. But all negotiation explaining that this is not a defect but improvement were not worth it. Sometimes for smaller defects, that took us 1 or 2 days to fix, we just left them as defects. And management didn't notice that, did actually close their eyes on this. But we considered the situations in our further planning. For instance, we had a budget, and we included certain percentage of errors in the future releases. We evaluated that around 5% of future defects that would take, that are not really defects, I mean 5 days, but tend to be improvements or the new wishes of the customer. But this should be written down somehow and described, because, okay, you forget it once, you forget it twice, in the end you won't find the roots of everything. Yes, that's what we call to cook porridge from eggs, if I can say that. But this is the management level communication. We can only provide the figures. We could prove the managers that, okay, we had certain number of defects, certain percent rates of defects, which were not actually defects, but were more like improvements. And based on the provided diagrams, management could further continue negotiating with the customer. But you could have informed at the beginning that it was not a defect. Yes, we could have, but it's more of a political approach. Sometimes we can do certain things for free instead of, you mean making additional developments, new improvements. Well, these are more political games, but we are only a test department. Our target was to clarify the picture. Well, I apologize, I probably missed the beginning of your presentation. We have the wonderful RCA. We're using standard templated RCAs, but however, we do not perform tasks after RCAs. Have you ever done this? Why then do you do RCA? Because everyone does. You see, when we understand what the condition of the system is, we have to do something about it. I assume you performed RCA because you wanted to see limitations of your systems. The main thing here is that the process has to be described and completed. And you also have to show that your actions affect the whole system. For management, it might not be clear why we spend additional time every week. But based on the statistics received, we could demonstrate that we would like to reduce a certain number of defects related to a certain domain. If you do it and if it works, the management supports you. What's the best question? The best question is the question asked by a lady. Thank you. I'll be glad if you email me about some of the defects that do not fall into the mentioned category, and the system could be then extended.